did it yesterday.
Okay, good morning, everyone. The way we start the class every day is, as I mentioned yesterday, the first thing is I would like to hear your questions about the homework, whether you did it on my lab or whether you did it, from the book. And once I answer your question, then we start the new material. So please go ahead. Which problems you had difficulties with yesterday? You can either unmute and tell me the number, or you can put it on the chat for all of us to see. So we get started. Please ask your questions. And that's the extremely important part of the course, that you guys ask your questions so I can help you if you have any difficulties. So go ahead. Don't shy away. Don't be shy. Just do it. Tell me which problems you had.
66.
Number 66. Okay, anybody else? Great. So we start with number 66 and then we proceed. So in my lab, they will have probably not exactly 66, but they will have usually very, very similar. So if we know how to do 66, we know how to do basically the problem they have. So yesterday we've talked about function, as you guys know, and the two examples I gave were the first example where I gave the function by using really a table, because sometimes there is no formula that will fit anything. So if you remember, I just came up with numbers. I didn't really, and so that's one way a function can be given to us. I just can give you a table of values and tell you the rule: 0 to 0, 1 to 30, to I think 45, and so on and so forth. And another one, a way the function could be, or the rule is given to us. We've talked about that we can given to us by a graph. And give it a rule by a graph means that for every input, whatever it is, the vertical distance from here to here is the output. That's how the rule is given. Number 76 is where the rule is given by a formula. So we will discuss this now, and we do 66. So number 66, we have the following function. F of x is given by the rule 2x squared minus 3x plus 1. Okay, that's the rule. What does this mean, a function given by this rule? It means that what the rule does. It takes an input. So x takes an input x, and it does something to it. What does it do to it? So this is my input. What does it do to it? It takes 2 times this input squared. So whatever you put here, it takes it and square it. Minus 3 times whatever you put here plus 1. So this is really the rule. You give it something, whatever you want to give it here, it square it, multiply it by 2, minus 3 times it plus 1. So before I answer exactly the question, which is I will be doing, let us a little bit practice this notation. And I know you know it, but make sure. So suppose what is f of 2? What does the function do? What's the rule? It's 2 times whatever the input you give it. Square it. Minus 3, whatever you input, multiplied it by 2, plus whatever you input, multiplied by 1. And then the rest is simple. You just do math. 2 times 4, that's it, 8, minus 6 plus 1, 8 plus 1, 7, minus 6, you get a 1. Okay. Let's take another situation. Suppose I take f of t. What is f of t? Please either write it on the chat or speak it up. What is f of t? Quickly.
It's that thing.
Sorry, whoever said something, I either didn't hear you or you have to unmute. Sorry, you have to mute yourself. Okay, so what is f of t? What does f do to it? 2, whatever you input t, it's squared. Minus 3t plus 1. Whatever you give it, that's what it does to it. Okay, let's take one more example. Suppose I ask what is f of, I don't know, x plus h, which is really what the problem is having. What does f do to x plus h? It does the following. Whatever you enter, so here my input is x plus h, that's my input. It does the following. 2 times whatever you give it. Whatever you give it and square it. Whatever you give it. Minus 3 times whatever you give it, whatever you input to it. Oh, I'm sorry. X plus h plus 1. Okay, so that's how it acts. You give it x plus h. It means what goes in this little blob here is x plus h. What goes into this blob here is x plus h and plus 1. So that's really the setup. Now the rest is some algebra. So let us do that algebraically. So it's 2 times. Now what's x plus h squared? So x plus h squared is x plus h times x plus h. Now if we multiply those out, we will get x squared plus xh plus xh, 2xh plus h squared. Okay, so I'm doing the algebra now. Minus 3x minus plus minus 3h plus 1. All right, one more step to simplify this tiny bit. So I will get 2x squared plus 2 times 2, it's a 4xh plus 2h squared minus 3x minus 3h plus 1. Okay, now usually we look if there is any way we can simplify things, but in this scenario I have xh, xh, there is nothing really to combine. There is really nothing to simplify, so that's of x plus h. Okay. Now, let me take the following. And then I do the problem. Suppose, so I take f of x plus h. Are those two the same thing? Can I take this h out? Yes or no?
No.
No, because here I'm adding h to the output. So h is added to the output. Here, my whole input is the x plus h. So f of x plus h, that's really simple. It means I take the function, which is, this is my function, and I add h to it. I'm done. So very, very different quantities. Here I add h to the output, and here h is part of the input. So very different ideas. Now what is number 66 about? It's just basically at the stage for us, it's just want us to train us with a function symbol. So they want us to compute or to evaluate this quotient. At least that's what I think it wants us. So let me check the book. Yeah, all right. So let us evaluate this quotient and simplify it. So I will do the numerator first. Actually, we don't need that. Equal to big line h. And that's a minus and a minus. All right. What's f of x plus h? So we just did the math. That's 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. F of x. F of x is, what does f do? It's 2 times x squared and minus 3x plus 1. Okay. And now we just do algebra. I mean, just simplify. There is really nothing deeper than that at this stage. So this is going to be equal to 2x squared. So I'll do it slowly. That's one. And then minus 2x squared minus minus plus 3x minus 1. And this whole thing would be over h. Okay. It looks messy, but as you realize, it will not be messy. Let us simplify. So we have a plus 1 here, and you have minus 1. They just basically simplify each other. I have a plus 3x minus 3x. Great, those are gone. Minus 2x squared plus 2x squared, they are gone. All right, and that's what I will be left with. I will be left with 4xh plus. So it's a good exercise in dealing with the symbolism of a function. So we're almost done. Now, if we look at it a little bit, we realize, I can kind of factor out this h in the numerator. So I will factor it out. And this leaves me with that over h. And this would leave me with 4x plus 2h minus 3. Okay. So the problem is important. Eventually, this quotient will play a very big role for us. But for today, the goal of this problem is really to learn how to deal with a function symbolically when it is given by a formula. Okay, please, questions before we move on? Anybody?
Yeah, are the homework questions the same as the MyLab questions?
Yes, yes, but there will be some variation. But the variation is actually very minor. What do I mean by minor? Like the book may be minus 3x. MyLab may put minus 4x.
Okay.
You see, that's how different they are. All right?
All right.
So I will do the one in the book because every student will have a different variation on MyLab, so there is no way I can do that. So that's why I am picking the same stuff. I'm picking the same problem from the book and from MyLab, but in class I have to do the one from the book. So, but the variation is really, really trivial. I mean, there is nothing much. It's good practice for you. So if you couldn't do it and I did it in class, it would be a good practice for you if they change it tiny bit. So you won't copy verbatim and you make sure you can do it. Okay, any other questions? All right. So today we're gonna keep working with functions. So I will, actually we'll be working with the function for like the first the whole semester, but the idea of reviewing pre-calculus, we will be doing it for the first basically 2 to 3 weeks. So I'm gonna go back to domain. So I mentioned domain yesterday and I will go back to domain. Okay. So what is the domain of a function? So if we have a function, it means we have a rule that you give it an input, it give it an output. So the domain, so why f of x is a function. So the domain are all the input values. Input value, it means all the x value if we call the input x. All the input values, or the x values if you want, that yield an output. In other words, what do I mean by they yield to all the input value that yield an output? Okay. Or in a more simple form, more simple meaning, all the x values for which there is f of x, for which f of x makes sense. I mean, you can find it. It's as simple as that. Okay. So let us find, the first example will be fairly simple. I did it very much similar to it yesterday, and then we proceed. So suppose I have a function which is given by a graph, like what I did yesterday. So I'm just gonna make up a simple graph. That's my function. So we're gonna do something like that, very simple. So it's a 0, I can take a 5 in here, and then that's it. That's here, this is 4. So in this function is given by a graph. What is the domain in this situation? All the input that yields an output. So which input yields an output? According to my graph, if I give you 6, there is no output because there is no graph for 6. So the domain in this simple problem is the closed interval 0, 5. Or you can write all the values of x such that x is 0, 0 included, and 5 included. So if the function is given graphically, you just look at the graph, and ask, okay, which input there is in output? So, and as simple as that. Now, if a function is given by a formula, which is a lot of time that will be the case, we have a little bit to be a little bit more careful. So I will give several examples. Suppose I give you the following function, f of x equal, let's say x squared plus x, something as simple. And that asks you the question, what's the domain of this function? It means which values of x I can put in here, and it will yield an output. So go ahead, I want a very quick questions. I want a very quick answer. Which value of x I'm allowed, and there will still be an output. Put your, use chat if you guys want. Sorry, somebody put something on chat. No. All real numbers. Is your classmate correct? Is there any value I can put? Yeah. No matter what you put here, you're gonna have an output. So here the domain, all real numbers. Okay, any number you give me, I can put it for x here and something will come out. I put 15, okay, that's 15 squared plus 15. There is no issue with that. Now, when there is an issue? There is an issue whenever the function in a way has a denominator in it. That's where the issues start showing up. So suppose my function, again, nothing hard, is like a 1 over, let us say, x minus 4. Okay, whenever there is a denominator, we know there is an issue because the denominator cannot be 0. So what's going to be the domain in this situation? It means which value of x? If I plug it here, there is no output. 4, because which value gives me problem? Every value that makes the denominator 0 is problematic. Every value that makes x minus 4 0 is problematic because 1 over 0 is not defined. So we need to exclude. Basically, we need to exclude, take away all x's that makes the denominator 0. Those has to be totally taken away. So, okay, x minus 4 equal to 0. It means x equal to 4. So the domain, we have to exclude that, all x's, such that x is different from 4. If I put 4, nothing, there is no. Example number 2 again. So whenever there is a denominator, we have to think. So suppose I give you the following, 1 over, okay, suppose I put x squared plus x, just for the sake of it. What is the domain? Okay, I'm always expecting answers.
All real numbers except for 0.
All real numbers except 0. So 0 is not in the domain. I agree, because if you put 0 in here, I'll have 1 over 0, doesn't make sense. Is it the only value not in the domain? You need to work a little bit.
-1 can't be x.
Negative 1 can't be. So because if I put -1, I will have -1 square, which is 1, minus 1 equal to 0. So -1 cannot be and 0 cannot be. Absolutely correct. But now, how can we do it algebraically? So we make sure that we are correct. I need
Set
to
the
find,
denominator equal to 0.
we have to set the denominator equal to 0 and solve, and then remove all those values. So we have first, we have to find out which value gives me problem in this particular problem. So we need to find, so we need to exclude all x's such that x squared plus x equal to 0. So let us solve this. How do we solve x squared plus x equal to 0? Remember, solving means factoring. To solve this, I need to factor. Means I need to factor my x. Because in this scenario, it's easy. X plus 1 equal to 0. So this gives me two values. X equal to 0. X plus 1 equal to 0. If x plus 1 equal to 0, it means x equal minus 1. So the value that makes the denominator 0 are 0 and minus 1. Now I am sure I'm getting them all. So the domain, all values of x, such that x is not 0. I cannot have 0 in the domain, and I cannot have minus 1 in the domain. So whenever the function has a denominator, we do have serious issue. Now, before I take my third example, I go back to example 3. What's the effect of, so fx equal 1 over x minus 4, the domain is all x at x different from 4. Now, what's the effect on the graph in this particular scenario? It means graphically, how do we see that, what's the effect of that on the graph? Graphically, what's happening?
At x equals 4, it goes towards negative infinity.
Maybe, I agree, but
and positive. Like, so it goes
right.
sort of like that.
Yes. And I'm going to be talking about that probably next week. But at least for now, you're absolutely correct. For at least for now, I'm going to do the easy stuff. It means at x equal to 4, there is no output. At least for now. Later on, we discuss what's happening. So there is no output. It means the function is going to be basically have two branches. One part will be here, and another part is going to be here. That's how the function looks like. So that's really what it means. It's not the domain. There is no output. At x equal to 4, there is nothing. There is no output. The function doesn't have an output. In this scenario, the function is going to have difficulty. So even if you pick up our calculator and we graph it, what's going to affect? At x equal to this x equal to 0. So the graph, there is no output at 0. And this is minus 1. There will be no output at minus 1. And the graph will be like 3 parts. I don't know exactly how it's going to look in this scenario, but we're going to have a part here. We're going to have some kind of a part here, and we will have a part here. So that's really what's happening graphically. Right, we're going to do 2 more examples, and we proceed. Now, the domain has difficulties whenever a function has a denominator. There is another place where we can have difficulties, is in the following. So I will put an example on the board, on the board, whatever, that's my board these days. So example number, I think 4, 5, I don't know. Suppose this is my function, f of x equal, let us say the square root. The square root of x minus 5. Simple. Okay. Whenever I have a square root, that is an issue. What's the issue in this problem? Which numbers are not allowed under the square root?
X has to be greater than or equal to 5.
Yeah, because whenever you have square root, the term under it has to be positive. Okay, square root of -1 is not defined as far as we are concerned because we only work with real numbers. So what condition I should put to be able to find the domain of this function? Which axes are allowed? All the axes that makes this term under the square root positive will be allowed. So what is the domain here? How to find the domain? We need to find all the values of x such that what's under the square root, which is x minus 5, is positive or equal to 0. That's really what we need. Okay, so to find the domain, I need to ask myself, okay, which values would make the denominator positive? Sorry, nonsense. Make the term under the square root positive. So basically, I need to solve this simple inequality. So how to solve a simple equality like that? X minus 5 bigger or equal to 0. It means I need x bigger or equal to 5. So the domain would be in interval notation. X bigger than 5, that's interval notation. Close at 5 and bigger at 5. So this is, we put plus infinity. That's interval notation. And without interval notation, all values of x such that x bigger or equal to 5. Okay, so whenever you have them under the square root, immediately a light should come up and you say, you know, I can't have something negative in here. So I'm only going to pick up what's positive. Okay, let me give you one simple example along those lines, and I will give you 2 minutes to see what your answer is. Suppose I take f of x to be 1 over the square root of 3 minus 2x. Okay, and what's the domain? So I give you like a minute to be able to figure it out by yourself, and then you tell me what your answer is. Work it out, don't guess. Work it out, don't guess. Are we ready? Okay, anybody would like to share their answers with us? Otherwise, I can pick one of you. I don't want to do that. Anybody would like to share their answer?
X is less than or equal to 3/2.
X less than equal to 3/2. That's your answer?
Yeah.
Okay, let's see. Is he correct? What do you think?
Can't be
no.
equal to, because then it would equal 0.
Right, the equal doesn't belong. Because if x equals 3/2, the denominator will be 0. So it's going to be strictly less. All right, so now let's do it algebraically. So you guys are right to do it algebraically. What we need is, we need to find all the axes that makes the curve under. For this one, I want this to be strictly positive. I'm not allowed to have it 0. So we need to solve this inequality, 3 minus 2x, strictly positive. That's what we need to solve. That's really what I need. All right, so let us solve it. So this will give me, I don't know, let me do it the hard way. Minus 2x, strictly larger than minus 3. Now to isolate x, I need to divide by -2. right? But since this is an inequality, when I divide by a negative number, I have to switch the sign. So we have to divide by -2. That's negative number. So this will give me strictly less than -3 over -2. It means strictly less than a half. So the domain is all x, such that x strictly less than 3/2, or in interval notation, everything less, it means from -infinity to 3/2 open at 3/2. And what's going to be the effect on the graph? So this is the domain. It means when I'm graphing, what is actually going to happen? This is 3/2. There will be no output here. So when you graph this, that you cannot find any output here because your x has to be less than 3/2. The function, and at 3/2, we're going to have like something going on, and the function is going to be probably something like that. That's how the function would look like. So there is no output here. The output occurs only when x is less than 3/2. All right, one more example. A little bit harder, but then we move on. So suppose my last example is the following. I'm going to take f of x to be the square root. So again, I'm playing with the square root of x squared, be careful, -4. Okay. I will give you a minute or so to figure it out, and then we discuss it.
Does that say x squared -4 or +4?
No, minus.
Minus, okay.
Absolutely.
All right, thank you.
Very good. I'm getting absolutely good answer there. All right. Everett, White, can you tell us how you got your answer? If you don't mind.
Well, since it's a square inside a square root, it'll have two answers. Okay, I kind of forgot how to explain it.
Okay, give it your best shot. All right, let's start with the beginning.
I had the answer, but I.
That's okay. Don't worry about it.
Brain fog.
What do we need? What's the term under the square root? X squared -4, correct? So what we need is, we need to solve this inequality. Strictly positive. It means I need to find all the x's that make x squared -4 positive or equal to 0. That's really what we need. So which x's make x squared -4 positive? I will do this problem in two ways. The first way is what I think you will do. And then I will do it graphically as well. So what I think you will do if you have this problem is the following. Okay, if x squared -4 positive, it means I need x squared larger or equal to 4. Am I correct so far? Okay.
Yes.
Then what am I supposed to do for x? It means what is x? So I'm going to do it algebraically first. So how can I get my condition on x from that?
Oh yeah, you have to square root it.
Square it.
Okay, very good. That's where the problem is going to come up. The square root. Great. All right. What's the square root of 4?
2.
2. So far, so good. What's the square root of x squared? That's the hard part.
X.
X.
Nope.
What?
What?
Plus or minus x.
Yeah. What's the square root of x squared? Okay, let me ask you the following question before I do that. Everybody is telling me the following. I need another piece of paper to make that idea clear. And one of your classmates almost has it correct. So suppose I tell you, everybody is telling me that, correct? And I have difficulties with it. Why I have difficulties with it? Suppose I have the square root of 2 squared. So x, I take x to be 2. Does the square root of 2 squared make sense? Of course, that's equal to 2. You're fine. Suppose I take x to be negative 2. Okay? Does the square root of x squared make sense in this case? Does it make sense? What's the square root of x squared? It's minus 2 squared. Since we're squaring, it still makes sense. But this is equal to what? Is this equal to minus 2? What's the square root of that? This is also plus 2, so it's not x. So the square root of the quantity minus 2 squared is not minus 2, it's actually plus 2. So what is the square root of x squared? Unless we know that x is positive, the square root of x squared actually is not x squared. It is the absolute value of x. It's a positive number. So square root of x squared. So if x is positive, you're right. So if x is positive, that's x, if x is positive. And if x is negative, this is minus x. So the square root of x squared is actually the absolute value of x. It's not x. So why I am bringing this up, why I'm doing this? Because the square root of x squared is the absolute value. It's not x. So if x square root of x squared bigger than 4, it does not mean bigger than 2. This doesn't tell me that x is bigger than 2. It means that in absolute value, it is bigger than 2. And that's important because if absolute x is bigger than 2, it means what are the values of x? Is x bigger than 2? What else can take? What else? Let me ask the following question. If does minus 3 satisfy this condition? Yes or no? If I put minus 3 for x, is this condition satisfied?
Yes.
If I put minus 15 for x, is this condition satisfied?
Yes.
Yes.
So which condition here? X should be greater than 2 or x is or x should be less or equal to minus 2. So which satisfy the condition x squared greater than 4? Everything bigger than 2, yes, and everything less than minus 2. So for example, if I take x to be minus 3, what will I have? Minus 3 squared is 9, it's bigger than 4. If I take x to be minus whatever, minus 4, when I square it, it will become 16, it's also bigger than 4. Okay, so the values of x are everything larger than 2 or less than negative 2. So my domain here, my domain is going to be all values of x such that x is larger than 2 or less than negative 2. Okay, so this is the only tricky one because of the reason that when you solve it the way you know how to solve it, you put x4 bigger square bigger than 4 and you take the square root of x squared is not x actually, is the absolute value of x, and that's really important. Because I didn't tell you x is positive, so we can have the absolute value, all right? If I want to think about this inequality graphically, okay, so graphically, If I want to think about x squared minus 4 positive, ask myself, if I graph x squared minus 4. So here I take the expression, so I'm going to graph the expression x squared minus 4. This expression. Now how's this? What's the graph of that? That's a parabola shifted down by 4 units. So graphically, this is that. Okay, I'm solving the same problem graphically. What are the intercept?
4, 0, negative 4, 0.
No. If I put this equal to 0.
Oh, wait a minute. 0, 4, 0, negative 4.
It
That's the
means
way.
x squared is 4. It means x is plus or minus 2. So this is minus 2, and this is plus 2. So when is this expression positive? This expression is positive up to here, and this expression is positive right there. So that's another way you can think of the problem in a purely graphical way. So you can take the expression x squared minus 4 and actually graph it and say, when x squared minus 4 is positive, it's positive for x larger than 2 and for x less minus 2. When is it negative? It's negative in between. Okay, so that's only basically the only hard part in the domain is when you have the x squared term, because we have to think a little bit hard. Right, now the range. What is the range of a function? So a function has input and output. The domain are all the input values. The range are all the output values. So what is the range? The range of a function. So the range is, so we have a function f of x. It means this function takes an object, we call it an input, and associate to it another object, we call it the output. And the range is the collection of all the output values. All the output. So the only way we're going to find the range is basically by graphing the function. We will not do anything algebraically for the range. We will find the domain algebraically, the way I did it in class, but the range we'll do it only graphically. So I will start with we'll take 2 simple examples. So what do I mean graphically? Suppose I have a function and I'm going to graph it. So I'm going to start here. I'm going to go up a little bit. I'm going to go down, and then something simple. I'm going to go like that. And I'm going to give you, of course, numbers. Otherwise, it won't make sense to you. So suppose I take this point. That's 2, 5. This point here, that's a 3, 0. And this point here, so let's make this point 4, minus 2. Okay, so that's really my function. First, what's the domain here? We've done this several times, but because I need to contrast domain and range. The domain are the input value that yield an output. So in my scenario here, this point is 4. So the domain here, and this is included, and this is included. So my domain is 0, 4. So the domain is here, the x value, that's the domain right there. That's the domain. What's the range? The output value. So let me ask you a very simple question. Let me call them y. Is y equal to 3 in the range? It means, is it an output value? It means, can you find an input whose output is 3?
Yes.
What? What do you think?
Yes.
Yes.
Give it to me.
Yes.
Of course, yes. Of course, yes. So 3 is down here. Of course, yes. So absolutely in the range. We have 2 different inputs. That gives an output of 3. Is 6 in the range?
No.
6 right here.
No.
You find an input? Definitely not. So what is the range? Quickly.
5 to negative 2.
5 to negative 2, because this is everything up to here and from here. So the range is this piece right there. That's the range of my function. All right, so the range is the interval -2 and 5, the output values. You just look at the graph and, oh, what are the output values? As simple as that. This is the range. Okay, another example, again, simple, because the range, as I said, we only do it graphically. We sketch the graph, we stare at it, and we ask ourselves, okay, what's really going on? So suppose I have this very simple example, f of x equal, let us say, 2 minus x squared. Okay, and my question to you is, of course, the domain, always, and then the range. Now, I didn't sketch it because I know most of you should know the graph of this function. All right, so what's the domain here, quickly? I'm always looking. The domain. Elizabeth, you give me the range. Domain is any x can go here. That's all values or real numbers. Okay, now what's the range? Okay, I have, of course, a correct answer on the chat. I need to graph it. What's the graph of 2 minus x squared? You guys know? X squared is a parabola. Minus x squared, it means you can do a parabola going down. So basically, you start with minus x squared, and you're going to shift it up by 2 units. So 2 minus x squared will be, this is 2, and that's my graph. Okay, so the range, as I said, we're really going to do a graphic. So what's the range? Everything up to 2. So that's my range from here to here. So the range is open here, minus infinity 2, and it's closed at 2. Right? So that's the domain and the range. So what the input and so domain, every input I can put. The range, you know, when you have all those input, you have output. What values are those output things? Right. The last thing we're going to discuss today is, I'm trying to follow the book because that will be the easiest for us, is when you have two functions, f and g, you can create a third function from it. So we're going to call it decomposition. So composition of two functions. It's fairly simple. Usually shouldn't have no issue with those ideas. So suppose we have two functions, f and g. So let f of x and g of x be two functions. Two functions. We're going to construct a third one. So we're going to create a third function. We call it the composition of two functions. So what's the composition? So the composition of f and g, composition of f and g, that has, it's a new function that has a specific notation. It's a new function that it's denoted by f, little circle, g. So that's the notation. So we're creating a new function. And that's the notation. What does it mean? So what does it mean for me to tell you what's the meaning of this function? So I'm creating a function f composite g is defined as follows. So what does this new function defined by? Defined in the following way. Telling you how a function is defined, it means I have to tell you what does the function do for an input. That's what it means to define a function. I have to tell you what rule does this function satisfy. It's defined like this. Okay, that's the picture, and then I will do the notation. You start with an x. That's how it's going to be defined. That's my input. And then basically you're going to let, if you want g to act on it, you get g of x. And then you take g and you let f act on g. And you get f of g. That's how the rule will work. So we start with x and we compute g of x. And then I use g of x as an input for f and compute f of g of x. So that's the definition of the composition. And that's what we call the composition of f and g. So if I have two functions, I created a third one called f composed with g. It's defined as follows. You take an input x and you compute g of x. Then you use g of x as an input for f and you compute f of g of x. Okay, not hard at all, but immediately example. So let us take the following example. Let f of x be the following. I'm going to just practice this example a little bit. So example, let f of x be equal to x squared minus 1. And g of x is 1 over x. Okay, 3 questions. Question number 1, evaluate. Let us evaluate f composed with g of 4. This is equal to what? Okay, verbatim definition. What's this? It's f of g of 4. Means we start with 4. You compute g of 4, then use g of 4 as an input for f, and you compute f of g of 4. Okay, thanks. So it's be equal to f of, what's g of 4? What does g do? It takes 1 over x. It means 1 over 4. So on the side, g of 4 is 1 over 4. That's my g of 4. And then f will act on it. What does f do to an input? It takes the input and it squares it, and then takes away 1 from it. All right, now a little bit of algebra. 1 over 4 squared, it means 1 over 4 times 1 over 4 is 1 over 16 minus 1. And common denominator, remember those, will give me 1 over 16 minus 16 over 16. And this would leave me with minus 15 over 60. And of the problem. Okay, now suppose I ask you to find g composed with f of 4. Is this the same question or different?
Different.
Different, because what's happening here? I start with 4 and then I evaluate f of 4. And then f of 4 becomes my input, then I find g of it. So this is g of, now what is f of 4? What does f do to 4? It squares it and takes away 1. So that's 15, right? Yeah. G of 15. Now what does g do to an input? It takes it 1 over 50. Okay. Now, one more problems and you guys will be ready. Suppose now we tell you find the following. F composed with G. What do they mean by find F composed with G? There is no input. When they tell you find F of composed with G, it means basically they want you to find the formula for F composed with G. It means they want us to find what does F composed with G do, not to a number like I did before, to any x. What's the rule of F composed with G? So when they tell you find that, it means they tell you what's the rule in general. But this is not hard at all. So what's the definition? It's F of G of x. Once you write it in this format, you're safe. So it's equal to what? F of, what's G of x? What does G do? G takes 1 over your input. So G of x is 1 over my input. Now F will act on it. What does F do? F takes the input and square it. Okay, my input now, that's my input. It takes it and square it. So whatever this is, whatever it is, it's gonna square it. And then takes 1 away from it. Now, if we do a little bit of algebra, a little bit, so we're almost there. I mean, that's fine. If we do a little bit algebra, just to practice this, what's 1 over x squared? It's 1 over minus 1. You can leave it like this if you want. All right. Okay, times is up. I will put the homework in, give me 10 minutes. The homework will be on Brightspace, also on my lab. And you guys can do them either way this week. I don't really, doesn't matter to me. Next week, you will have to do them on my lab. And I remind you that at 10 o'clock, I have office hours. So not 10, 8, sorry, we start too early. At 9 o'clock, I have office hours. So if you guys have any questions, please drop by. Okay, good luck. See you tomorrow. Any questions? Any question before I end?
Yes, so we can view the homework questions on Brightspace, even if we don't have the book and the access code for MyLab yet?
Yes. That's what I did yesterday. Absolutely.
Okay, cool.
So right now, I'm going to put the homework. You have to give me 10 minutes because usually I put the homework after the lecture. So I make sure I don't put homework that I didn't cover. Right now, I will put problems, on Brightspace, which are and the same one I put on my lab. So this week you don't have my lab, you just pick them up from the book, if you have the book. Did I answer the question?
Yeah, thank you.
Okay, all right. So, bye. I'm gonna end the meeting now. Bye, guys.